Hello, welcome to Tech Talks.
In this session, we will learn to solve problem, mainly efficiency and voltage regulation of a three-phase system using nominal T and nominal pi method. Most of the time, what you study in your theory, there are a lot of formula that you have to remember to solve this type of problem. Here we will see that the easiest way to solve this problem, much formula remembrance is not required, some basic concepts are required, and also we will connect our solution with the phasor diagram, that how this phasor diagram comes and does this phasor diagram have any implication or not, we will see in this numerical. So as you could have seen, I have written a question that determine the efficiency and regulation, voltage regulation of a three-phase system. The system is 100 kilometer transmission line, 100 kilometer transmission line, 50 hertz transmission line that is delivering a load of 20 megawatt. Delivering a load of 20 megawatt at 0.8 power factor lagging. So the power factor is 0.8 and it is lagging power factor, and the voltage is 66 kilovolt to a balanced load. The resistance is 10 ohm for 100 kilometer, that is the 10 ohm is total resistance. Inductance and capacitance are 11.17 you have 10 to the power minus 2 Henry and 0.9954 microfarad for 100 kilometer respectively. Now we have to use nominal T and nominal pi method. So first I will show you using nominal T method. So the circuit diagram would be like this. By inductance, resistance. This is Vs sending end voltage. This is Vr receiving end voltage. This is IR receiving end current. This is IC capacitor current. This is IS sending end current. Okay, now the resistance is 10 ohm, so 10 ohm that will be divided into 5 ohm and 5 ohm. This is 5 ohm and this is 5 ohm. Now the value of L is 11.17 into 10 to the power minus 2 Henry. The value of XL is omega L, that is 2 pi F into L, so that is equal to 11.17 into 10 to the power minus 2. It is 35.09. 35.09 ohm. And the value of XC is 1 by omega C, that is 1 by 2 pi FC, that is 1 divided by 2.50 into C. The value of C is what? 0.9954 micro. 0.9954 micro. So it is coming as 3197.81 ohm. Now this capacitance, this one will be minus jxc, that is minus jxc 3197.81. Now this inductance or XL, this will be divided between these two parts. Okay, so the value of each one will be J, positive J, 17.55 ohm, and this one also positive J, 17.55 ohm. So these are all the values that we have got. Now we have got a voltage 66 kilovolt. So 66 kilovolt is which voltage? 66 kilovolt is actually this voltage between this point, that is VR. VR is actually 66 kilovolt, but 66 kilovolt is line voltage, so we will make it phase voltage. Okay, so we will calculate everything in per phase system. So VR is 66 kilo by root 3, that is equal to 38105.11 volt. We will take this VR as reference, so the angle will be 0 degree at 0 degree volt. 38105 at this much volt. 66, let me check once again. 66 kilo divided by root 3, 38105.11. Okay, now we were talking of the current. The current, how we will find out? Current is equal to, so no, this 20 megawatt is the power that is supplied. Where this power is supplied, this is the output power. That means this power is supplied over here. At what power factor? At this power factor. That means this is the angle, that is cos inverse of 0.8. This is which angle? This is angle between this VR and IR. This VR and IR. So how we will find out IR? We will find out IR. That is root 3 root 3 VR. VR means VL. Root 3 VL IL cos phi is equal to power. So in place of root 3, we will be writing root 3. VL is line voltage. Line voltage is 66 kilo. IL we will writing IR cos phi. Cos phi is 0.8. Power is 20 mega. So from here you can see that IR, this is equal to 218.7 ampere. 218.7 ampere, right? So this is actually magnitude of I. Okay, so what will be IR? This will be 218.7 at an angle of minus 36.87 degree ampere. From where this I got this 36.87, because that I am showing you, power factor is 0.8, so cos inverse, so 0.8 is equal to 36.87 degree. And here is another term, you see a lagging. So this lagging means that the current is lagging the voltage. Now we will draw the phasor diagram of whatever we have done. Okay, so this is VR, current is lagging by minus 36.87, so this is current, that is IR. This angle is 36.87 degree. Yeah, that's 37.87 degree. Now moving to the next. Now we have to find out that what is the voltage of this capacitor. Voltage in this point. Okay. So this VC capacitor voltage, we can find out is that this capacitor voltage is actually voltage of this part VR plus current into impedance of this branch. So this is equal to VR. VR is what? VR is 38105.11 at an angle of 0 degree plus IR. IR is what? IR is 218.7 at an angle of minus 36.87 degree into this branch impedance, that is 5 plus J 17.55 ohm. Now this one comes to what we will see. This one comes to 38105.11 plus 218.7 at an angle of minus 36.87 into 5 plus 17.55 I and we will convert this one to polar form. Okay, so what is the answer? The answer is 41353.37 at an angle of 3.35 degree voltage. So if we try to draw this the phasor of this part, so you could easily see that if this is IR, so IR into R will be in this direction, parallel. This part is IR into R. This one is IR into J XL by 2 into JXL by 2, that is this part and this part. So the total voltage, that is VR plus this voltage is this here, that means this is VC. You could easily see the magnitudes. You see the magnitude is 41353.37 and the magnitude of VR is 38105.11. So obviously this VC magnitude is greater and it is ahead by 3.35 degree. That means this angle, this small angle is 3.35 degree. Okay. Now moving to the next part. So in the next part, you see we have found out the voltage across this capacitor. Now we will find out what current is going through this capacitor. So to find out the current IC, this is equal to VC by minus JXC, VC by minus JXC, that is VC is what, 41353.37 at an angle of 3.35 degree and divided by minus J into this value, that is 3197.81. Okay, now this is coming as 13 at an angle of 93.35 degree ampere. So IC is 93.35 degree, but a positive angle has come. So our reference was this one, VR, because we have taken VR as angle 0. So IC will be where? IC will be 93.35 degree ahead of VR. Also you see IC, the magnitude is 13, whereas IR the magnitude is 218.7. that means almost less than half. IC is less than half of what is IR. So this is 90 degree to VR, it is 93.35. so I will put it here. I am using a red pen. This is IC. Okay. Now IS, this current is equal to IC plus IR. The sending end current is equal to capacitive current plus receiving end current. So IS, this is equal to what? IC plus IR. This is equal to what? 13 at an angle of 93.35 degree plus IR. IR is what? 218.7 at an angle of minus 36.87 degree. So this is equals to what? This is equals to 210.54 at an angle of minus 34.16 degree ampere. Okay. Now you check that IS, this is at an angle of where? Minus 34.16. IR, this was at an angle of where? Minus 36.84. So IC is just ahead of IR. IS is just ahead of IR. Okay, so let us check in phasor diagram. So we draw the vector over here. You can check it yourself that IR will be lying over here, IR. Now this angle, the angle between VR and IR, this is equals to 34.16 degree. VR and IR, this is IS. The angle between VR and IS, this is equals to 34.16 degree. Okay. Now we have found out IS. Now we will be finding out what is VS. Similarly, how VS can be found? VS is very simple. Likewise, we will find out where VS is equals to this voltage plus this voltage. This voltage is VC. So we will directly put the value of VC. VC is what? This value. So we will directly put the value of VC, that is 41353.37 at an angle of 3.35 degree plus this voltage. This voltage is what? IS into this much. IS is what? IS is this one, 210.54 at an angle of minus 34.16 degree into 5 plus J 17.55. So this is equals to what? VS. VS is equals to 4 as 497.26 at an angle of 6.3 degree volt. So from here you could understand that VS is 6.6 degree ahead of VR. 6.6 degree ahead of VR. VC is where? VC is 3.35 degree ahead of VR. Now we will be checking that if it fits with the phasor diagram or not. Since IS is here, so IS into this resistance will be parallel over here. So will be 90 degree to it. And this total this will contribute as VS. Now the angle between VS and VR, that means this angle. Now this angle is what? This angle is 6.3 degree. Okay, so it fits with the phasor diagram, and obviously we don't have to remember any other formula that how it will be solved or not. We have just followed simple circuit theory. Okay, now we will be finding out the voltage regulation and efficiency and all other things. So voltage regulation is what? Voltage regulation is no load receiving end voltage minus receiving end voltage, no load receiving end voltage minus receiving end voltage divided by receiving end voltage. Okay, so we have to find out no load receiving end voltage. So no load receiving end voltage means what? No load receiving end voltage means that a condition where no load current is flowing. No load current is flowing means what? No load current flowing means IR equal to 0. So if IR is equals to 0, that means this voltage is only divided between this part IR is 0, so this voltage, VC voltage, this will appear over here. But the condition is what? The condition is this current should be equal to 0. Okay, so since we have got the Vs, what is Vs, so we can easily find out what is this voltage. How? By voltage division rule. Okay, so Vs at no load condition, that means no load, so this will be VR. VR at no load condition. VR at no load condition is what? J minus J 3197.81 divided by this total impedance. The total impedance is what? 5 plus J 17.55 minus J 3197.81 into Vs. Vs is what? Vs is this voltage. We were only taking the magnitude. It is 44497.26. That is equals to what? That is equals to 44746. 44746. Okay, now percentage regulation we will be calculating. This percentage regulation, it is what? VR by NL minus VR divided by VR. So you put values, okay, and they will be finding that the percentage regulation will be 17.4%. Now next we will be finding out efficiency. So efficiency means what? Efficiency means output by input. Okay, output by input. So output we know that the output is 20 megawatt. We don't know the input. So input, how we will find out? That is power input. Power input we can find out in most of the way that we can calculate the losses in the resistance, because there the losses will be there. Inductance and capacitance, no losses will be there. And also we can find out straight away from the input voltage and input current. Okay, so what is the formula? That is 3 V phase I phase into cos phi, right? So 3, what is V phase? That is Vs, that is this voltage, that is 44497.26 into I phase. I phase means what? I phase means Is. What is the current? 210.54 cos phi. That means the angle between Vs and Is. So what is the angle difference? It is 6.3 plus 34.16. Okay, so this will be the power input. So this power input will be how much? This power input will be 21.38 megawatt. Okay, now for efficiency, we calculate the efficiency. That means P output by by P input into 100%. P output simple 20 megawatt. P input 21.38 megawatt into 100%. Okay, so 20 divided by 21.38, this is equal to 93.54. that is 93.54% efficiency. So you can easily see that we have calculated efficiency, we have calculated voltage regulation, but we have not remembered any formula that is given. We have just used our basic knowledge of phasor diagram, and also every angle what we have got, we can easily connect it to the phasor diagram. Thank you. So likewise you can solve the problem for pi model also. Pi model, same thing, draw the circuit diagram, and then from power, similarly you can solve the problem. Thank you.